Supplemental Math Videos from Circle Christian School. Today's video is how to set up your 3-ring binder and just a reminder of what your homework front page should look like.
The right triangle. So many neat, good parts. Remember, the right triangle has a leg, and both of those are attached to the 90-degree angle, and a nice long line between the legs called the hypotenuse. Hypotenuse. Cool. So there's all sorts of things, obstruction, proportions, ratios, then the sides, and that's what makes a right triangle cool. Now, remembering what to do with these guys is the important thing. Remember, if you have two sides, any two sides, is a squared plus b squared equals c squared to go find the third side. So, for instance, maybe you have one side that's a 5 and another side is, let's use 25. And notice how it's broken up here, that we have a leg, which is going to be your a squared, another leg that you're looking for, which is your b squared, and the hypotenuse, the guy always across from the 90-degree angle, is going to be your c squared. Have two sides, looking for a third, Pythagoras. So we're going to 5 squared plus the b squared, and it's going to equal the c squared of 25 squared. All right, let me pause for a second, see if I can get rid of the jiggles. Let's see if this is any better. Okay, so we get 25 plus the b squared equals 25 squared, which is 625. And so we're going to minus 25. And that's going to give us 600 equals b squared. Got to get rid of the square. The inverse of squaring is to square root, which means we're going to have to square root both sides. So b is going to equal the square root of 600, which you can do by calculator, or we can do it as a radical. You have to be able to see it in both forms, because in testing situations, they're going to give you the radical and they may give you the approximated calculator form. Got to see them both. So this is going to be what? 60 and 10. This is going to be 6 and 10. And the 10 is going to be 2 and 5, both prime numbers, so I'm going to circle them. And let's see, the 6 is 2 and 3 down to the primes. And then 10 is, of course, 2 and 5 down to the primes. And it takes 2 for 1 to escape, so we have a 2. It comes out. We have 2 5s. They come out. And everybody else stays inside. So we have a 3 and we have a 2. Remember, they're factors, so that means everything's multiplied together, whether outside or inside, and we get 10 square root 6. So over here would be 10 square root 6. Very good. Or whatever the square root of 600 is. Our next way to deal with the right triangle is looking to see what we've been given. Of course, we have right triangles, so I'm just going to put the nice little right inside there. And if we have two sides that are congruent, or if we're shown that we have two angles that are congruent, we know that this is going to be the isosceles right. That is the 45, 45, 90. And we check to see what the ratio is. And we have x, 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 square root 2. And then we check at different things that we've been given. For instance, maybe the hypotenuse is 6 square root 2. Okay, without a calculator, we know we're just going to go back to the sides here. Squigglies are still in the pen. And it's going to be the 6. Likewise, sometimes it's not perfect or pretty, and we have the isosceles right triangle. For instance, maybe this side is 3 square root 2, a leg, which means the other side is going to be 3 square root 2. The sides are the same. And we have to go to the hypotenuse, which is 3 square root 2 times the square root of 2. 2 times 2 in square root form just comes out as a 2. So we have 3 times 2, which is going to give us 6. And likewise, we can walk backwards. Notice we multiplied to go forward to the hypotenuse. To go backwards, we're going to have to divide by the square root of 2. So this would be 6 divided by the square root of 2. We have to make it proper. So we're going to multiply both top and bottom by the square root of 2, which is going to give us 6 square root 3 over the 2. Simplify real numbers here, and you get that 3 times the square root of 2, which I just noticed. I have this thing of thinking ahead here, which is what I was doing, was thinking ahead. This should be a 2. And that gives us 3 square root 2. So if you notice that neat little mistake before I did, make sure you put it on your paper for 10 extra stars. All right, let's move over to the special right, where all 3 sides are different, but the inside angles are 30, 60, 90. And remembering that the ratio for that is small side times the square root of 3, and then the small side doubled for the hypotenuse. As long as you have one angle, you have both angles. You may be given the 60, you may be given the 30. Very good. So now that's going to be the special right triangle, 30, 60, 90. And you just always start at the small side. So let's say the small side is 4, which means the medium side is going to be 4 times the square root of 3. And then we're going to go from the small side again to the hypotenuse. 4 times 2 doubled is going to give us 8. Okay, we can walk back from anywhere. To go find what we have. Maybe the hypotenuse is the only thing that you've been given. So let's say the hypotenuse here is 10 square root 2. So we have to go back to the small side, which means we're going to divide out the 2, and it would be 5 square root 2. And then we're going to move to the medium side. So we have 5 square root 2 times the square root of 3, which is 5 square root 6. And we're done there. Special lit. One special angle, one side. No calculator needed. Then there are just those days where we have a right triangle, where we've been given just one side. Oh, let's say we're given the side over here of, let's call it 8. And we've been given one angle. This looks like about 65 degrees, so that's the angle I'm going to use. Which means we're going to have to get out our little trig hand of life and follow the system here. First we have to use our thumb and make a target. After the target, second finger, identify, find the hypotenuse, find the opposite, find the adjacent. There it goes. Next, what we have to do is third finger, figure out if we're going to use sine, cosine, or tangent. Well, I have to find a hypotenuse. I've been given an opposite, O and a H, so I'm going to use Mr. Saw of the Katoas. So sine 65, our target angle, equals O over H, so 8 over the H. All right, fourth finger, multiply or divide. Since the H is in the denominator, we're going to divide by the trig. And you're just going to have to kind of excuse the wiggly pen here. I have to stop the whole program, start it over again to do it. And I want to get this out to you. So using our handy dandy little calculator, we would find H. Next we take a look and go, well, I need an A and I have an O. So OA means I'm going to use tangent of the SOHCAHTOAs. So we just go tan 65, the target. And that equals the O over the A, so 8 over the A. And again, variable in the denominator, so we're going to divide by the trig. And there you go. All right. All right, let's try an example of where we have sides but no angles. Okay, get our setup here, got our right triangle. And let's say we have a 5 here and a 7 here, which means we can always find the hypotenuse here. Remember that when we solve for a right triangle, it means we're finding all the angles and all the sides. So we would use Pythagoras to go find the hypotenuse. 5 squared plus 7 squared equals our hypotenuse squared. 25 plus 49 gives us 74. So this would be the square root of 74, which you can keep as that, or you can do the calculator and find out approximately what it is. For right now, I'm just going to leave it as the square root of 74. And now what we have to do is go find an angle. Don't have any angles. Got plenty of sides. Same thing happens. You're going to have to make a target, follow the trig hand of life. So I make a target, which means that's the angle I'm looking for. It can be an X, it could be theta, it could be U, it could be A, whatever. Got to go find that angle. Then we have to identify. Well, we have a hypotenuse, we have an opposite, and we have an adjacent. My clean numbers, try to use clean numbers as opposed to something radical or decimaled out because it's just not as clean. I have 5 and 7, which is an O and an A, so that tells me I'm going to use tan. And because I don't have the angle, I'm going to use my pinky finger, the inverse finger, the -1 finger, and it equals O over A, or the 5 over 7. And you're going to put it into the calculator just like that. Going to use the second key, tangent, because we want the words up top, which says tan -1. And then we're just going to put the ratio in, 5 divided by 7. And you get your angle. Yay! And that's how you do that. All right, just a quick tip. What you can do with your calculator there is get some of that painter's blue masking tape or some colored tape. I don't think Scotch tape will work too well. And put it over your keys and put the little SOHCAHTOA on it with maybe a skinny little Sharpie. And you'll have your trig ratio sitting there waiting for you. Like I said, everything goes back to a right triangle. So as you go out in life here and you take a look at things in accordance to the earth and otherwise, there's neat little right triangles that happen. Of course, they happen in geometry and shapes. You can get a right triangle in a circle, or a right triangle on a trapezoid, a right triangle in a parallelogram, even in a hexagon. There's a right triangle, and we'll be talking about those really soon. But I'm just going to go out to nature here and solve some right triangles. Let's say we want to find the height of a tree. We can do it by its shadow and an angle of elevation here. So we do the same thing. We make a target. Always identify, have our hypotenuse, our opposite, our adjacent here. So we take a look at what we're looking for. We have an O and an A. So that means we're going to do tangent. So tangent the target, 65 degrees, equals O over A, so that's X over 8. Variable in the numerator, so we're going to times by the trig. And lickety-split, we have the height of the tree at 17.61. Do I want 61? 16. There we go. Feet high, no, meters high. That does make a difference. All right. So now we're going to do the flag. How tall is the flag? And again, all we need is the shadow and the angle of elevation. Lots of different ways to figure that out, even by using your protractor and a string, putting it up to your eye. Look to where you're going. The string will give you a reflex angle here. So again, we're going to make our target. Identify, H-O-A. See what we have? Oh, look, another O and A. Usually when you're looking for height and you have shadows, you're going to end up using tangent. So we have tangent 50 equals A over 10. And the height of the flagpole is at 11.92 feet tall. Just about 12 feet tall. Nice and regal. And then trigonometry actually gets used an awful lot in things like navigation. Here's our nice little lighthouse beaming its way toward the ship out in the ocean. And on this one, what we want to do is find the height of elevation, the angle of elevation for where the lighthouse is in accordance to the ship. So this one, we're actually looking for an angle. Gonna do the same thing. We target, we identify, hypotenuse, opposite, adjacent in the water here. 2 clean numbers. Oh my goodness. We're just going to do this whole page in tangent things. Do not know the angles, so there's our pinky finger. The -1 is going to equal O over A, 620 over the 2000. And of course, you can actually work with the big numbers, but anytime I have zeros over zeros, I just kind of get rid of them. Makes it nice and smaller. For an angle elevation of 17.22 degrees. And there you have it. Cool things that happen with right triangles.